guys, it's me, Ren, the guy standing right there. Say hi, me. Yeah, see how you had literally one word and you managed to stutter before it? Yeah, that's why you're playing a video instead of talking in real time. Go sit down, you're blocking the gif of the entire SpongeBob episode. Is he sitting down now? Okay, cool. Alright, so some of you might remember my lofty goals from the start of the year being to not only make a polished game with at least one level, but also to make a series of development logs for YouTube and catalog my process and advertise. It was pretty clear after the first month that was way too much to do, so I decided to switch it to just one video at the end of the year that cataloged the whole thing, and that's what you're watching right now. Okay, so how did the game part of this actually go? Really well, actually, but you'll notice that I haven't shown any footage of it yet. There's a reason for that. After about 350 hours of work on the project, I got a software crash and the files got corrupted, which is whatever. It happens all the time. That's why we have backups, right? So I go to Google Drive and I get my backup, and all of the backups were backups of the wrong file, and I had nothing. You could imagine that that was pretty depressing, and I kind of went on a spiral for a few months and only picked up game development recently again. How recently? Last 2 weeks recently. Everything you're about to see was made in the last 2 weeks, this video included. I'm writing this script at 8:51 a.m. Thursday the 16th, and I'm reading it on, let me check here, 2 a.m. the 17th. You could say I'm cutting it a little close. Alright, let's back up 2 weeks and walk you through how I got to where I'm at. Upon starting up a blank project in GameMaker, the first thing you need to do is create a sprite. A sprite is fancy game dev talk for the visuals of the game. To start, we're going to need 2 sprites, one to represent the player and one to represent the walls. Normally during testing you just make 2 different colored cubes to start, but I felt like doing a bit of art, so I made some sprites for the main character too. Oh yeah, I should probably talk about what the game actually is. The original concept for the game was actually made by my sibling a decade ago, back when games like Flappy Bird, Subway Surfers, and Doodle Jump had a death grip on the mobile gaming market, and everybody was like, mobile games are the next big thing, consoles are dead. My sibling saw a formula. Simple, arcade-styled gameplay, appealing, kid-friendly mascots, and 2-word catchy names. So they set out to make their own spin on the trend for a high school project. Caffeine Cat, where you would play as a cat and catch falling cups of coffee to rack up score. That's it. Unfortunately, game development turned out to not really be their thing, and they dropped the class before they got very far in the project. Fast forward a few years, and I became a game developer myself, and the rest of our family told me that I should make Caffeine Cat. I tried to explain to them that it was a boring concept and that it wouldn't work in today's market, but they kept insisting, and this went on for a few years until the beginning of this year when I had an idea. If they were gonna get their cat, it was gonna be on my terms. I stuck to the theme of a coffee-obsessed cat, but the gameplay would be my own. I decided to make it a momentum-based platformer where you'd run around different places and try and get as many coffee cups as you could, as fast as possible before completing the level to achieve a higher score. Okay, back to actually making the game. After making the first few sprites, I got to work on coding the first few objects. What's an object? It's what you put code in and then you put a sprite over the object to make it look like stuff. Okay, for our wall object, we actually don't need any code at all. All the wall object needs to do is take up space in the room, a room basically just being a level editor. Think Mario Maker. The player object, of course, is going to need a lot of code, the brunt of it. To start coding, we need to put an event into the object. An event decides when the code that you put into them actually runs. You almost always want to start with a create event, which will run the code put into it as soon as the object is created, which happens basically as soon as the game starts running if you put it in the room. The create event is mostly used to define variables, which can be literally anything. I can type in chicken_nugget equals 0 into the create event, and then whenever I type chicken_nugget anywhere else, it'll be the same thing as typing 0. Note that any blue text you see is a variable that was previously defined somewhere else by me. Next up, we want our step event. A step event triggers every single frame of the game, or step. Commonly, games, including this one, run at 60 frames per second, so anything I put in here is going to be ran 60 times per second. First up, we want to define some temporary variables. They're basically the same thing as variables, but they can't be used outside of the context you establish them in, so in this case, can't use them outside the step event. At the top here, I set up several temporary variables that I can use to check if certain keys on the keyboard are being pressed or not. The reason I set them up here instead of in the create event is because if I set them up in the create event, they would only check the keyboard on the first frame the game opens, which isn't particularly useful. Then we set up another temporary variable called dir, which is equal to key right minus key left. Now hold on a second. Key right and key left aren't set to numbers, so how does this work? Well, the keyboard check function returns a 0 if the key isn't being held, and a 1 if it is. So holding right, dir will be 1, holding left, dir will be -1, and holding either both or neither key will be 0. Next, I add my direction, multiplied by the previously set acceleration variable, to my horizontal speed variable. As much as I'd love to go over every line of code like this, I've only got 15 minutes, so I'm going to speed it up a bit. Next, I check if we're holding a direction or not, and if we aren't, we slow down. These two lines check if I'm in the air or on the ground and slow me by either the friction of the ground or the resistance of the air, respectively. These lines cap my speed at a certain amount so that I don't just accelerate forever, but instead of hard capping the speed at a certain value, they make the speed slowly decrease back down to that value so that you can still move faster than a running pace in certain situations. This block of code is what calculates gravity, reducing vertical speed at a constant rate, which is set to be slightly lower if the player is holding jump, to give them more control over their jump height. For both wall jumps and normal jumps, I implement the use of a jump buffer. A lot of times when playing platformers, you'll want to jump right at the edge of the platform to get the longest possible distance, but it sucks when you're a 60th of a second too late on the button press and end up falling into a pit. What the jump buffer does is it gives you a few frames of airtime where you can effectively jump off of the air, preventing frustrating moments like that. It might sound like nothing or kind of stupid, but I guarantee you if you've played a modern platformer before, this has definitely saved you more than once. As for the wall jump, some people find it instinctual to hold away from the wall at the same time they jump, despite this not actually being the required input. You just need to jump. This often results in them drifting away from the wall before the game can read the jump input, resulting in another frustrating moment. I don't actually know if other games do this or not, but I put it in mind because I used to have that issue and I empathize. Interestingly, this actually results in a bug where if you jump during the buffer time, while you're not holding a direction, you'll jump straight up the wall. And if you jump after sliding just over the top or just below the bottom of a wall while holding towards it, it results in a sort of vaulting motion, catapulting you past the wall at high speed. These types of bugs are what we in the game development industry refer to as surprise game mechanics, and I like leaving them in because they're fun and interesting, and not at all because I don't know how to fix them. There's obviously a lot more code than that, even just in the player object, but we've been looking at words long enough. Let's take a look at some pictures. Here are all of the sprites for the cat and what they're for. Oh yeah, floating coffee cups. Let's talk about those. Outside of being a collectible item, I wanted them to contribute to the gameplay in a more meaningful way. I went through a lot of variations on what they should do, but eventually settled on this. During the course of the game, there's going to be a caffeine meter at the top of the screen slowly ticking down. If the caffeine meter runs dry, the cat falls asleep, acting as effectively a game over. Upon touching the cup, the cat latches on to the side and begins drinking the coffee, floating in the air indefinitely. You can then press space to jump off the cup, basically gaining a second jump. Alright, let's talk environmental visuals. Here's the level zoomed out a bit. Between the sprites for the cave-looking area and the grass-looking area, how many sprites do you think there are? Let's see here. For the dirt, you're going to need one to go on top with the grass, and then the pure dirt one on the bottom, and then you'd need two for the rocky part as well with the same logic, so 4, right?
Well, Mr. Funny Man, is this how you get your sick kicks?
What? It's just an ordinary crabby. Oh my goodness! Squidward!
Try 156. Okay, that's an exaggeration. There's actually only 94 that are used in the game, but there are 156 sprites there. What we failed to consider during our earlier analysis was that if you want sprites to merge together smoothly, you need one for every possible situation. On the corner, that's a sprite. On the side and on the corner, that's a second sprite. On the side and on 2 corners, that's another sprite. You see where I'm going with this. Anyway, one last thing to cover. What's this weird stretched thing at the end about? Well, that's a feature that has not yet been implemented at the time of me writing this, and will remain a mystery unless I finish it after this, in which case future me, take it away! If you're hearing this, future me did not take it away, my bad, did not finish that. Feel free to ask me about it, I'd be happy to tell you about it, it's really cool. Anyways, listen to this banger OST.